Keeper 5.2 related rates. All right, so when you guys set up your problems, what you want to do first is read the problem thoroughly. Like you want to read the entire problem. Once you read the problem, then you want to answer 3 questions, and you literally want to write these 3 questions down. So the first question is no, and basically you're saying, what do I know? What rate is given in the problem? They're going to give you some rate that you must know. Then number 2, you want to say, what do they want me to find? Like what is the question asked for? What rate or what are they asking for in the question? And then part 3, they're going to say when something happened in the problem. So they might say like when X is this, or when Y is this, or just when something. And once you know that when, you should be good to go. So again, you're going to do KFW for every single problem, which is your know, find, when. A quick way to remember that is Kentucky Fried Whales. So again, KFW, Kentucky Fried Whales, that's your know, find, when. And you want to write that down for every single problem so that you know what you're actually looking for and what you have. Once you write those 3 things down, you want to find an equation that relates your know to your find. So if your know, for instance, is volume and your find is radius, well, then you would use an equation that involves volume and radius. All right, then you want to take the derivative of your equation. So um, again, once you get that equation that's involving your know and your find, you want to set it up, write the equation out. Usually it's like a geometry equation, and then you'll take the derivative of that equation to try to find whatever you're looking for. Once you take the derivative, you'll plug in your when. So whatever when they gave us, you'll plug that in, and then you'll simplify to get your answer, and make sure when you write your answer, you label it with units. All right, so example 1, it says Joe inflates a spherical balloon. Air is entering the balloon at a rate of 5 centimeters cubed per second. How fast is the radius changing when the radius is 10 centimeters? So first thing I do is I set up my KFW. So my know from this problem is volume. And I know it's volume because they're talking about air entering a balloon, so they're talking about filling up some space. Not only that, I know it's volume because it said centimeters cubed per second. So my know is dV dt, and V stands for volume in this case, equals 15 centimeters cubed per second. Next, I want to see what they want me to find, what they're asking for in the problem. So in that second sentence of the problem, it says, how fast is the radius changing? So that means I'm trying to figure out the rate of my radius, or dr dt. And then continuing on that second sentence, it says when the radius is 10 centimeters. So my W, or my when, is radius equals 10 centimeters. Now I have to try to figure out an equation that involves volume, since that's what our know was, and radius, since that's what my find was. And I know from geometry that the volume of a sphere is 4/3 pi r cubed. All right, so using that formula, I'm going to take the derivative of it. And again, just remember that we're taking this derivative with respect to time. So anytime I see a variable that's not in terms of t, I have to put d whatever over dt. So when I take the derivative, I get the derivative of v is dv over dt equals 4 pi r squared dr dt. Again, that was just a basic derivative on this right-hand side. The only variable we had on the right-hand side was radius, so that's the only thing I had to take the derivative of. Now that I have that derivative, I'm going to plug in my know and my when. So I'm going to plug in 15 for dv dt, and I'm going to plug in 10 for r. Now simplifying that equation to solve for dr dt, I get dr dt equals 15 over 400 pi, which reduces down to 3 over 80 pi centimeters per second. All right, example 2. We have a piece of ice cut in the shape of a cube, melts uniformly so that its volume decreases at 3 centimeters cubed per second. How fast is the surface area decreasing when the edge of the cube is 5 centimeters? So again, I'm going to start by placing my know, find, when. So what I do know from the problem is that the volume is decreasing by 3 centimeters cubed per second. So we have dV over dt is negative 3 centimeters cubed per second. What they're asking us to find is the surface area of the cube. So I'm going to call that ds dt. And then when, if you read the last part of the question, it says when the edge of the cube is 5 centimeters. Now, if I know the edge of the cube is 5 centimeters, I also know that the volume of the cube is 5 cubed, which is 125 centimeters cubed. Now, next step, I want to try to find the equation that relates volume and surface area. I don't know an equation off the top of my head, so I have to kind of create an equation. So I'm going to start with volume, and I know that volume equals E cubed. And knowing that, I can rewrite that in terms of E, so I could say E equals the cube root of volume. Now, using that information, I could also write an equation for surface area. And surface area is 6 times E squared. So you have 6 times the cube, and each area is E squared. Now, replacing E with the cube root of volume, I get surface area equals 6 volume to the 2/3. Now, taking the derivative of both sides, I get ds dt equals 4v to the negative 1/3 times dv dt. Now, plugging all my knowns, I have 4 times the volume is 125 to the negative 1/3 times dv dt, which is -3. And simplifying that, I get 4/5 times -3, or negative 12/5 centimeters squared per second. Next example says a ladder 10 meters tall is leaning against the vertical wall with its other end on the ground. The top of the ladder is sliding down the wall. When the top end is 6 meters from the ground, it is sliding down at 2 meters per second. How fast is the bottom moving away from the wall at this instant? So again, I'm going to start with my no. And my no is that the top, or the y value, is sliding down, so it's decreasing, so I have a negative 2 meters per second. They're asking me to find the movement of the x, or the part of the ladder that's moving away on the ground. And they told me that my y value was 6, so the top end or the wall part of the scenario is 6 meters. And then I also know if the top end is 6, then the bottom end, or the x value, must also be 8. And I know that because the ladder is 10 meters tall, so it's like a 3, 4, 5 triangle. All right, so setting up a formula, I know I can use Pythagorean's theorem since I'm dealing with the right triangle. I have x squared plus y squared equals 10 squared. Understand that the length of the ladder is not changing. So when I take the derivative, I get 2x dx dt plus 2y dy dt equals 0 because the length of the ladder is a constant. All right, now simplifying that, I get, or plugging in my values, I get 2 times 8 dx dt equals, and I went ahead and moved the y stuff to the other side, so negative 2 times y, which was 6, times dy dt, which was negative 2. Now solving for dx dt, I get 16 dx dt equals 24, or dx dt equals 3 over 2 meters per second. A right circular cylinder of constant volume is being flattened. At the moment when its radius is 3 centimeters, the height is 4 centimeters, and the height is decreased at a rate of 0.2 centimeters per second. At that moment, what is the rate of change of the radius? So again, setting up my no find when, I have no is dh dt is negative 2 over 10 centimeters, or negative 1/5 centimeters per second. We're trying to find the rate of the radius, so dr dt. And we know we're trying to find it when r is 3 and h is 4. So again, setting up a formula that involves h and r, or height and radius, I can use volume. So volume equals pi r squared h. Now understanding this problem, that volume, they told us, is constant. So the volume the whole time is a constant, meaning that when I take the derivative, the volume's derivative becomes 0. So I get dv dt equals 2 pi r h dr dt plus pi r squared dh dt. Understand that I use product rule to do that first times the derivative of the second plus second times the derivative of the first. Now when I plug in my values, again, dv dt goes to 0. I plug in my r and my h, and I also plug in my dh dt. Now simplifying this and solving for dr dt, I get 18 pi over 10 equals 24 pi dr dt, or dr dt equals 3 over 40 centimeters per second. A boat is pulled into a dock by a rope attached to it and passing through a pulley on the dock positioned 5 meters higher than the boat. If the rope is being pulled in at a rate of 2 meters per second, how fast is the boat approaching the dock when it's 12 meters away from the dock? So I'm going to set up a little picture. And again, when I set this picture up, I need to understand that this piece up here is like my dock. So the dock is 5 meters higher than the boat. And this R value is the rope that's pulling it in. So now setting up my no find when, I know that the rope is being pulled in at -2 meters per second. I want to find dx dt, or my horizontal distance of how far or how fast the boat is approaching the dock. And I know that I'm trying to find that when I'm 12 meters away from the dock. And if I know that I'm 12 meters away from the dock, and I also know that the dock is 5 meters above the boat, I can use Pythagorean's theorem to figure out that the rope must be 13 meters. All right, so now setting up Pythagorean's theorem, I have x squared plus y squared equals r squared. And so taking the derivative of both sides, I get 2x dx dt plus 0, because the height is not changing, equals 2r dr dt. Now plugging in everything I know, I have 2 times 12. 12 was x. dx dt equals 2 times 13, because r was 13. And then dr dt was -2. Now simplifying that, I get dx dt is -13 over 6 meters per second. A man 6 feet tall walks at a rate of 5 feet per second towards a street light that is 16 feet above the ground. At what rate is the tip of the shadow moving? At what rate is the length of his shadow changing when he is 10 feet from the base of the light? Alright, so that's my little picture. This 16 is the street light over here. This is my man 6 feet tall. His shadow will be out to the left of him, and X represents his walking. Alright, so we know his walking, or dx dt. We know his rate is -5 feet per second. And it's negative because he's walking toward the street light. If he was walking away from the street light, it would be positive. What we're trying to find in this question, they're asking us two things. They're asking us the rate of the shadow, and they're asking us the rate of the tip of the shadow. And they told us that when we're trying to find these values when x equals 10. So I'm going to start with ds dt. I'm going to start with the function itself, and I'll worry about the tip later. So I'm going to set up similar triangles, like a ratio between the triangles. And I know that this long side of 16 relates to the entire bottom of the triangle, which is x plus h. And that's similar to the man's height to the base of the little triangle, which is s. So you can kind of almost see like a big triangle, which is the black triangle, plus you have this smaller triangle, and I'm creating a relationship or ratio between those two. All right, now if I cross multiply, I get 16s equals 6x plus 6s. And then if I subtract the s to the other side, I get 10s equals 6x. And now that I have kind of a nice looking formula, I can go ahead and take my derivative. And taking my derivative, I get 10 ds dt equals 6 dx dt. Now plugging in what I know, I get 10 ds dt equals 6 times -5, or 10 ds dt equals -30. Dividing by -10, I get ds dt equals -3 feet per second. Now, if I want to find the tip of the shadow is simply your x length plus your s length will give you the tip. This right here would be your tip. So if I add x plus s, I get my tip. And so tip equals x plus s. Therefore, the derivative is d tip over dt equals dx over dt plus ds over dt. Now, plugging in my values of dx dt, which was -5, and ds dt, which was -3 that we just found, I get -5 minus 3, which means our tip dt is -8 over feet per second. A water tank has the shape of an inverted right circular cone with a radius at the top 15 meters and depth 12 meters. Water is flowing into the tank at a rate of 2 cubic meters per minute. How fast is the depth of the water in the tank increasing when the depth is 8 meters? So here's our picture. And we have a no of dv dt is 2 meters cubed per minute. We're trying to find the HDT, or the height, or the depth of the tank, and they told us when H is 8. So creating a formula for V and H, I have V equals 1/3 pi r squared H. That's the volume of a cone. And I don't want, notice I don't want this R in my problem. And the reason why I don't want this R is because I have nothing that relates to R over here in my know, find, when. So what I'm going to do is I'm going to set up a relationship between R and H. Again, like a similar type ratio type situation. So R is to H as 15 is to 12. In other words, R equals 5/4 H if I multiply both sides by H. Now taking that R and plugging it into my equation that I have for volume, I get 1/3 pi 5/4 H squared times H, and then simplifying that, I get 1/3 pi 25 over 16 H cubed. Now if I take the volume of both sides, or sorry, the derivative of both sides, I get dV dt equals 25 over 6 pi H squared dH dt. Plugging in everything that I know. So I'm plugging in H is 8, and I plugged in dV dt is 2. And then simplifying that, I get dH dt is 1 over 50 pi meters per minute. A balloon rises at a rate of 3 meters per second from a point on the ground 30 meters from an observer. Find the rate of change of the angular elevation of the balloon from the observer when the balloon is 30 meters above the ground. So again, here's my picture, and I'm just plugged in everything they told me from the picture. I know that my y height, or my vertical height, dy dt, the rate of it is 3 meters per second. They want me to find d theta dt, or the angular elevation, the rate of the angle of the elevation, when y is 30. Alright, now if the distance on the ground is 30 and y is 30, I can set up a ratio using like SOHCAHTOA to figure out my theta. So if I do like tan of theta is opposite over adjacent, 30 over 30, I get tan theta equals 1, which means that theta, using my unit circle, had to be pi over 4. Now setting up that same type ratio, I have tan theta equals y over 30. Notice I'm using 30 here because that is the distance on the ground, and that's constant. He's not walking back and forth. That 30 is constant. So then taking the derivative of both sides, I get secant squared theta, d theta dt equals 1 over 30 dy dt. Now calculating my secant of theta, if I'm at pi over 4, if theta is pi over 4, then secant theta is root 2. So I have root 2 squared d theta dt equals 1 over 30, and then dy dt they told us was 3. Now simplifying that, I get 2 d theta dt equals 1 over 30. Dividing both sides by 2, I get d theta dt is 1 over 20 radians